So I'm really excited to introduce you folks to Azam, as you probably already do know him. Azam is an esteemed software developer with over a decade of professional experience in the industry. Throughout his career, he has held key positions as a lead mobile developer for prominent companies like Fortune 500 companies, including Valak, AIG, Dell, Baker Hughes, and Blinds.com. Azam's experience extends to his role as a highly sought after instructor on popular learning platforms such as Udemy and LinkedIn, where he has successfully mentored over 75,000 students. Currently, Azam serves as a lead instructor at Digital Crafts, imparting his extensive knowledge of software development. Thank you so much, Azam. It's all yours now.
Thank you so much, everyone. Let's go ahead and share my screen. Okay. There we go. You should be able to see now everything.
Yep.
Okay. All right. First of all, thanks everyone for being here, and thanks to Women Who Code for giving me the opportunity to speak. My name is Mohammad Azam. I go with my last name, which is Azam. I'm on Twitter at Azam Sharp, iOS developer, coding bootcamp instructor. I also do instruction on Udemy and LinkedIn. So I have a lot of courses on iOS development, and I speak at different conferences also, like speaking at Swift, and I was there at New York 50 and others. So this is kind of like a little bit of, I would say, fast-paced session. I will be sharing 3+ years of experience, or whenever SwiftUI came out, like 2019. It might be very different for you, because I think most of the people who are using SwiftUI are maybe not using it correctly, or they're using it in a very different way. So you will, when you see the session, you might have like a shock, like, okay, what just happened? But keep in mind that, this took me like it took me 3 years to get to that conclusion that I was using it wrong, and I was, starting on the wrong foot. But let's move to 2019, when Apple introduced SwiftUI. Now, I was really happy at that point, because I was like, well, SwiftUI is kind of like React and kind of like Flutter, and I have already used these things. So it's very similar. And I teach React for a living, and I work with Flutter, so it was a no-brainer for me. I was like, okay, it's pretty simple. But then comes the question, well, which pattern should I use? Because in a UIKit application, I would always use MVC, because that's kind of like the default. But SwiftUI is kind of like, well, what should I use? So I took the approach of not even thinking, just blindly following what other people were following. And I'm like, okay, I'll just use MVVM, because not because it's everyone else is doing that, but because I'm just blindly following it without anything. All right. So I wrote a book on it. Apart from that, I also published many different articles on it. This also included podcasts. So I was always promoting MVVM. All right. So I did a lot of videos on MVVM. I started promoting, writing more and more and more articles. I created courses on MVVM. So I did a lot of stuff promoting that, hey, this is the right pattern to use. But deep inside, I was still confused. I was like, this is not really working out. So I'm writing a lot of code, and most of my applications are actually client server and core data. So these were the main kind of application that you probably design. I mean, although they can be different, obviously, but I think most of us are designing client server applications. So this is a simple application that has like 4 or 5 screens. Let's say you can add a movie, you can display a movie, you can review a movie, so all of those different things. And I will end up with all of these view models. And that was like, okay, why am I ending up with all of these, view models? I mean, all of these things I was writing just for an app that has 4 or 5 screens. All right. Hold on a second. And this was a kind of like an architecture. You can see over here, and this is the kind of like architecture that you may have already seen also. You can see the movie list view, add movie view, and every single view contained a view model, a corresponding view model. We have all done that. So I was also doing the same thing. So this was kind of like a flow that I was following. And then there comes a part that, okay, I need to access the environment object. I need to get the information to all of my views that are deeper into the hierarchy. So what should I do at that point? Well, I can pass in as a dependency and to a dependency to a dependency, and that makes it much harder, right? I mean, if you have ever tried to access or pass environment object in your view model or try to access environment object in the view model, it becomes very, very hard. So I'm like, okay, this is not what I really want to do. I think I'm fighting the system over here. This is getting harder and harder. This is not how I used to build React or Flutter apps. We didn't really use MVVM in Flutter apps or React apps. So I'm like, okay, let me do some research because I'm definitely not taking advantage of the system. So I learned about the MVVM model. And by the way, I have used MVVM before. It's not the pattern, it's us, the developers. The pattern is just best practices. Now, if you try to squeeze in the pattern and shove the pattern incorrectly, that's your fault. That's not the pattern's fault. I mean, I can put my shoes in a refrigerator, and then I can blame the refrigerator that, hey, why the shoes are cold? Well, obviously, you put the shoes in the refrigerator. So there's a place for everything. So I started learning about MVVM. MVVM is obviously called presentation model, and you can see it's dated. It's like 2004 and even before. In WPF application, which was from Microsoft, and I had the pleasure of working with WPF applications since there are a lot of oil and gas companies in Houston. That was the main thing that where Microsoft kind of marketed presentation model pattern into MVVM. This is a very typical WPF application. On the left side, you can see a XAML file. On the right side, you can see a C# file. The XAML file on the left side is basically, so this side is all of this is basically the user interface. You're creating a text box, you're creating something else. And on the right side, you have a C# file, a view model. And you have different files. You have one file for the XAML and one file for the view model. And the reason for this is because in WPF, and it's a pretty old technology now, there is no way to bind them together. Like the view, which is right here, does not know how to bind. So if it needs to bind, it needs a view model for that. But if we look and fast forward to SwiftUI, I can create the same app like this. I don't really need to create a separate view model for anything. I mean, that's it. That's the simplicity. That's the beauty of it. That if I need to create a add movie view, where a add movie view can allow the user to add a title and the year of the movie, this is as simple as it looks like. And that is, I think, what messes with the developers. When they see the simplicity, they're like, this can't be right. So let me just make it more complicated. How can I add some coordinators to it and the routers to it and interceptors and layers of layers and layers? And it becomes the whole mess. Well, how do I validate these things? Well, it depends on the validation. If you're trying to validate that your text fields, like the title text field and the year text field are filled, if the form is valid, then I will literally put the validation inside the view right here. This is going to validate that the form button is disabled or enabled based on, well, if you're entering something in those text boxes. Again, I have not really created any view model. The view model, usually when people talk about view models, they're talking about an observable object, a point, a source of truth. In this case, I don't really need an extra thing for anything. I mean, I will just put in the title, I'll put in the year, I will write the property, and that's it. This is actually no different from HTML, client-side validation. And I know HTML because I teach that. I mean, that's my background, web development. If you know HTML, you can already read this stuff. The first one is input type text right here. And the required attribute right over here is telling us that this field is required. So it's just the presentation logic. The same goes with this part, which is saying that the value that you're going to type in is not only required, but also it has to follow a certain pattern. And the last one also, it is required, the text field is required, and it has to follow a certain pattern. Like in the text box, if you type in something in HTML with the wrong pattern, like ABCD or whatever, it's not going to work. So it's the same exact logic over here. So that is why I'm putting it in the view. So the view itself, what I learned, is different in SwiftUI. We'll get to that. But what about if I have a much bigger form? Like I have not only the title and the year of the movie, but I also want to save the genre of the movie and posted URL of the movie. Well, in that case, you can separate it out. Right over here, you can create a data struct, a simple struct, a value type, and you can hold those values in the value type. And that's it. I didn't really have to create a observable object or a view model for all of these approaches. I just made it simple. This is all exposed or talked about in Apple WWDC videos. So in other words, the view in SwiftUI is the view model. And I think this is where people, it shocks them that, okay, hold on, what is he saying? Oh, so I should just start putting all my domain logic in the view model. No, that is not what I'm saying. And this is the point that people, usually developers, get stuck on. Okay, I have this business logic because I was checking the bank account. I should put it inside the view. No, that's not what I'm saying. The domain logic belongs in the model. The presentation and the transformation logic belongs in the view. The presentation logic can be UI validation. We already seen that, form valid. Transformation logic can be, well, maybe you have a date in your database and you want to display it in a different way. So that can go inside the view using the formatted modifiers. The domain logic is very different. This should not go, and I repeat, not, this domain logic should not go inside the view, which is the view model, because domain logic is your brain of the application. That should go inside the model. And we're going to see a little bit of it, that what domain logic is. Domain logics are actual business rules, all right? So in other words, when I look at this architecture that I was following earlier, when I had a view and then I had a corresponding view model associated with the view, which probably all of you have been using this, this model doesn't scale well because you will have billions of these view models that are not really doing anything. So I removed all of those. And again, I'm talking about the client-server application over here. So I removed all of those things, and then I replace it with what I like to call it aggregate model, or just the model. You can call it anything you want. This is not an official name, aggregate model. It's just the name that I've came up with on like thin air. You can call it Scooby-Doo model if you want to, that's fine. But the whole job of the aggregate model is simply to provide the data to the views. That's it. Simple. So instead of having 3, 4 different view models, now you have one large model. You can call it view model, you can call it whatever, that is providing the data to the view. And the reason is that the source of truth is the same. If I go back over here, the source of truth is the server. In a client-server app, the source of truth is always the server. So if the source of truth is the server, why do we keep making these models observable object? Because every time you declare this observable object, that's the source of truth. But that's not the source of truth. Source of truth is right here. That is the source of truth, the server. The source of truth has not changed. It's the same. And that's the reason you should not be creating in a client-server app different view model for every single screen. And this is also shown by Apple in their implementation. I'll show you that slide. Most of the people have not seen those videos because it only happened for a split second. But let's take a look at the consuming API, because that's a very common operation that you will do. Consuming API simply means that you're consuming a JSON API, and how would you do it? Well, there are multiple ways, right? If I'm building an application to display list of conferences, like, like a conference like like the Women Who Code conference, like a TriSwift conference, SwiftUI conference. And I don't want to update it. I don't want to add the conference. I just want to display all the conference. Then your code can be as simple as this. That's it. I mean, that's the whole code. No view models, no nothing, nice and simple, nice and clean. You can see it easily. What I'm doing is simply accessing some sort of a HTTP client. This is the thing that actually gets you the data. It will eventually populate the conferences array. I get the data, I populate it, and then I display it. Done. It can be as simple as this. And this is a special case because in this case, I'm not allowing the user to add a conference. They're just consuming the data. They just want to display the conference, not edit it. They don't want to add a conference, edit, delete, nothing, just displaying the conferences. All right. And this has been talked about in one of the sessions, WWDC 2020, Data Essentials in SwiftUI. And if you remember the diagram that I created earlier on, it's actually very similar to the diagram that you see over here. The aggregate root is able to get the entities and display it on the screen. All right. If you want to look at application from Apple, there's one application, the sample app. There are multiple actually sample apps called Fruta and the food truck applications. The food truck application, if you just search for food truck application SwiftUI, you'll be able to download it. That application just uses JSON files. So it gets the data from the JSON file. So it does not really show you that these files are, these files are actually getting from somewhere. Let's see if I can, I don't really see my, oops. I don't think I can activate that. But so the food truck application that Apple has, it only shows you data from a JSON file. But there is one of the WWDC videos, it's called Use Xcode for Server-Side Development. And that shows you exactly how to read the data from a JSON file also. All right. So one of the questions is, HTTP client is an interface or concrete class? It can be anything you want. If you are using an unmanaged dependency, that's a good question. Let me actually go over here. Yeah, so if you're using an unmanaged dependency means that a dependency that you do not control, then HTTP client can be an interface because probably you have to mock it because you don't control it. In my application, in the one that I'm showing, I control the dependency. I host the server. I'm creating the conferences. So I don't even want to mock it. If I want to do anything, I'll just go to the real database, real server, and I'll test it right there. I don't want to mock it because you mock unmanaged dependency. There's no point of mocking a managed dependency unless your managed dependency is like super slow. Then you can do it. But good question, yeah. So you can see that Apple is doing kind of like the same thing. The food truck model, and that's the entire model of their application, is observable object. And that is the source of truth. And look at what they have. They have truck, orders, and server donors. And that food truck model is known as aggregate model. That's what I call it. You can call it anything you want. That is managing the state of the entire application. Now, for Apple, they create like medium to small size app, that's fine. But when you create larger size app, then it becomes a little bit different. And this is what my model kind of looks like now. There we go. I mean, you can obviously call it model, you can call it movie app model, you can call it anything. So this is kind of like it looks like. All right. So this model, so I'm not creating every single view model for every single screen that I will add. Since the source of truth is a server, I will simply create one model. You can call it aggregate model, model, data store. People call it data store also. And that kind of like manages the entire state of your client server application for at least a small to medium size app. And I think that removes a lot of complexity for your application because you don't have like 30,000 view models now for every single screen that you have. And if you want to use that, You can use it in many different ways. I usually use it from an environment object. I just inject it as an environment object. I get it inside the view that I want. And then if I want to add a new movie, I'll just call the add movie and I'm done. So this means that when I add a movie, it will go to the server, it will update the server in the database and add a movie. But when the data is returned from the server, it will also update the collection that was managed by the model. So if you look over here, it should have a collection of movies, right? So it is after adding the movie, that movie will be added to, I should probably use this. So after adding the movie, that movie will also be added to the movies array. And since movies array is marked with publish, all the different views that were looking at the movies array, they will get refreshed. So you don't have to do anything. It's already taken care of. Nice and simple. All right. And I think that's the thing that bugs most developers. It's too simple. It's too simple. It cannot be right. It's just too simple. It's not going to scale. It's just, we need to make it, where are the different 30 different layers that we want, right? So in the end, what actually happened is that we removed all the view models and we just replaced it with a single model. Now you can call this MV pattern, data store pattern. I don't care. You can call it anything you want. All right. MV pattern or MV is not some official name. It's just something that people invented. All right. So if you talk about, hey, I'm using MV pattern, they probably will not know what you're talking about. But I think if you show them the code, then they'll say, okay, now I understand. So you can see that the difference is clear. In a client-server app, if you're creating view model after view model after view model, look at that. I mean, that is what I was doing. On the left side, you have movie list view model. Then every movie list will contain one movie, right? You want to display a single movie? Well, that is managed by a movie view model. You want to display a review, then there's a review view model, movie detail view model. You have all done that. I have done that, but now I'm not doing it anymore. All right. And the reason is the code is not an asset, it's a liability. So the more code you write, it's not better, it's a liability. More code you need to test. It's saying that, but in this case, our business logic is tightly coupled with the HTTP client. Well, the business logic is actually not in the HTTP client. The business logic is right here in the model. So there you go. All the business logic that you're going to write, the client is simply getting the client over here, the movies HTTP client is simply getting the data. It's completely stateless. It's not holding any data. And the beauty of movies HTTP client is that you can use it in a UIKit application, and that will work just fine too. All right. So the logic will be right there in the model, not inside the HTTP client. HTTP client is just making a request using URL session and just getting the data, not holding the data, just getting the data, stateless, and returning you the data. Actually, you can see pretty much right here, I guess. If you look over here, there we go. All right. So movies client is simply calling load movies. It actually gets you the movies and gives you the result. All right. Now, if you want to use a different movies HTTP client because you're managing unmanaged dependencies, then probably not use a concrete class. You should use a protocol over here. Right. You should use a protocol. So you can mock it or do whatever you want. So there's no logic in movies HTTP client. If that's what you're thinking, that's wrong. All the logic is inside the model. So code is not a liability. Code is not an asset. It is a liability. All right. So remember that. So the more code you type is not better. But what about bigger apps? I mean, yeah, we can create one model to control the entire application or entire state of the application, but my apps can be very complicated. Well, in those cases, what this diagram is actually from Apple. So what this is saying is also that you can divide it. You can create multiple models, but not based on the view that you're adding. It is based on the bounded context. So now I'm diving into the terms of domain-driven design. So let's say you're working in an e-commerce application. You can have a catalog, you can have fulfillment, you can have inventory. These can be their own big models that can manage, different entities that they do. I mean, whatever the work that they're doing. All right. So the more complexity, the more complicated your app is, well, you will add the model based on that complexity. Yeah, I'll share a link. You can access the PowerPoint. Yeah. Okay, where am I? There we go. And in a larger application, it kind of looks like this. All right. You have catalog UI, you have and catalog UI and catalog on the top over here, this does not mean there are different projects or packages, although they can be. You can see over here, I wrote a comment over here that they represent a folder or a package dependency. All right. So catalog UI can be a folder with all the UI stuff related to catalog UI, and the catalog can be the model which manages all the stuff related to the catalog. The same goes with inventory UI. It's just a folder. Inside there are views which are doing something with the inventory, displaying inventory, adding inventory, updating inventory, something like that. And then remember the model that we talk about, the aggregate model? Well, that's inventory. So we don't have add catalog view model, catalog list view model, catalog detail view model, catalog update view model. No, we don't have that stuff. All right. The view is the view model. And then we have this data access layer, the green one in the middle. That is your actual, the layer, the HTTP generic kind of a layer that can get you all the information. And the last one, the red one, is like if you have like shared stuff, you can put it in a shared package or shared folder. Yes, we will. Yeah, we will have a QA also. Okay. Now, I wrote a very, very detailed article, so detailed that most of the people didn't really bother to read it. It was so long. But if you go on my website, adamsharp.com, you should be able to find this article. It's very long, but if you want to read it, just read modular architecture and understanding the MV pattern. I think, and well, I guess you have to read till multiple aggregate models also, but that will allow you to have a much better understanding that it was what's going on. All right. But do your research. I mean, depending on the company that you're working with, they might be already following some architecture and changing these things. And these things takes a little bit time to learn. So see what fits your needs. For client-server application, that is the architecture, at least that's what I use. But what about core data applications, right? Core data and Swift data now, if you have played around with Swift data, is a thing. I mean, people use Swift data or a core data at least. Swift data will be used and replacing core data. So when I started using core data, I was just creating very simple apps like movie list view. And then you click on a button in movie list view and it opens up a add movie view, like a sheet or a modal. And I would add the movie in the sheet, but now my movie list view needs to refresh. But how do I do that? So what I ended up doing is by using, whenever the sheet was dismissing, I would do populate movies. So I would again go to the database, and not a big deal. I mean, it's a local database, who cares? And then I will populate the whole thing again. So that will work. And I'm like, okay, I mean, that doesn't feel reactive. I actually had to write the code to refresh the movies. I can also use combined publishers and all that stuff. Or I can do this crazy stuff. I can go ahead and implement my own NS fetch results controller. So you can see that I'm using a movie list view model over here. And inside the movie list view model, I implemented kind of like the old techniques of UIKit, right? UIKit using the NS fetch results controller. And the reason for doing that, or what happens with this, is that now whenever you add something to the movie database or movie table, sorry, it will automatically fire the fetch results controller, and all of the things will automatically be refreshed because you're using the NS fetch results controller. But that's a lot of code, and that's just adding a movie. Now you have to add a review to the movie, you have to update the movie, you have to do this, do that, and that is a lot of code. All right. So I was fighting it. I was fighting the framework because there is a much easier way to do all of that stuff, which is just use NS, just use fetch request or section fetch request, and you're done. And fetch request can be used in many different ways. Over here, you can see that inside the view, and fetch request can only be used inside the view, which is a view model. Behind the scene, the fetch requests are doing the same thing as NS fetch results controller. Whenever you're going to add a new movie or a new list in this case, it will automatically refresh your user interface. And if you don't want to put the request, a complicated request in your view, like if it's a complicated request, then you can extract it out. Like over here, I have added a request using mylist.all that is going to return you the request, and you can just feed it to the fetch request. But if you're doing that, I would first look at the view, what the view is doing, because at that point, I would start composing my view into a way that it can be reusable. So view becomes more of a composable item or a composable, you can divide it much further on. Although you can do it, mylist.all is perfectly fine. But I think if you are reaching that point that you have your predicate is so long that you have to put it inside a actual model file of core data, then maybe your first attempt should not be this, but to divide the view much further to see what's going on and create container views. And core data is very similar, although not the same, but very similar to nhibernate, Lightspeed, Link to SQL, Entity Framework, SQLite. I've used all of these ORMs. Core data is not really an ORM, but it can use benefits from the active record pattern. Active record pattern is very much used in your Ruby on Rails app, and pretty much most of the apps that actually does this, ORM. So, and I put a tilde because it's kind of like you can use active record pattern and not like completely. I did try to use it completely over here. You can see that what I did over here is I created a protocol for model, and all of my different core data models were then using the model protocol, and they can save it, they can delete it, they can perform all requests or find requests and all that stuff. On the right side, you can see that how will I save my list. I just create the list, assign the name, and then call .save. You can do that, that's perfectly fine. One problem you may get is with the Xcode previews, because sometimes you need to create a fake shared context, and using this approach will prevent you from doing that. All right, so even though I did it, in the end I found out that the better approach is to put all the business logic inside your models, meaning your entities for your core data, but the save operation and the update operation and delete operation, just use the manage object context that you can access from environment variable. That is a much better approach in my opinion. So for Swift UI and core data, I ended up using more of like an active, kind of like an active record pattern. It also helps me with Xcode previews. I mean, if you look at this Xcode previews and I'm using the fetch results over here, this Xcode preview is not really going to work correctly because somebody needs to pass in the reminders to it, right? I mean, if you see on the second line, the reminder list view will only work that if somebody passes in the reminders to it. But since reminder is a fetch results, the only way you can kind of pass in the reminder is using a fetch request. So the way to do this is to create a container views. So again, this is shown in structure your app for SwiftUI previews in WWDC 2020. You can create container views. You can see the container view is called reminder list view container underscore previews, and well, reminder list view container, and that has a fetch request, and now you can preview that. So container views come in really handy when you are trying to build something related to core data, because the container can have the fetch request, and then you can pass it down to the child view, which in this case, my main view, reminder list view. There's a great talk on lessons learned rewriting SoundCloud and SwiftUI. And this was, I believe, in NS Spain a few years back. And they talked about the same thing. They were using MVVM, they were using Viper also for some reason. And what happened is that their app was rejected by Apple because Apple was saying that your app is 10 times slower than the competition. We cannot accept this app and put it on the App Store, so fix it. So what they said that, okay, we start writing the app in a way that Apple would write the app. So we let go of our concerns about the architectural layers and all that stuff. And suddenly our app was just faster because we were using fetch request property wrappers, section fetch requests, and all of those things, because all of those things are very much optimized to be worked with SwiftUI. So if you're using fetch request property wrapper, section fetch requests, and all of those things, they are very optimized by Apple so that they can work with SwiftUI. So that's the reason Apple included those things. And if you haven't really looked into Swift data might be kind of like a proof that how Apple wants you to write application. Once again, I have a very long article on Swift data that you can definitely read. It's called The Ultimate Guide of Building Swift Data Application. It's on my blog, azamsharp.com. And in this article, I talk about the same thing, that it's kind of like the proof that Apple is telling you that, hey, we are creating these property wrappers, and I don't know what you people are doing by working your way around it. Just use those property wrappers, all right? And check out Swift Data WWDC videos, and you'll be like, oh, so this is how they want us to use it. Just put the query property wrapper in the view, which is a view model, and then use it. Now, one of the questions when I give this talk is, well, what about testing, right? What about testing? How can we test? How can we make it faster? How can we test everything? Well, for me, testing is about confidence. How much confidence do you have that your code will work? Now, my views of testing might be very different from probably all of you might go for 100% of the testing. I don't really go for 100% code coverage or 100% everything to be tested, by the way. And the reason for I don't go for 100% code coverage is that I'm not sending anyone to Mars, all right? And neither are you. Probably you're not. If you are sending anyone to Mars for exploration and there is human life depends on it, then yes, you should probably do more testing. 100% will be the minimum in those cases, all right? Or if you're creating something, a device that, I don't know what those devices are called, that keeps a person alive, those devices, if you're creating those things, then you should do 100% testing, absolutely 100%. I'm not creating those things, okay? I'm creating like a CMS apps, I'm creating simple apps, complicated apps. So for those things, I don't really go for 100%. Also, code coverage has nothing to do with if your code works or not. Code coverage can be a good negative indicator, but it's not a good positive indicator. What that actually means is that if you have a very low code coverage, then it can be a concern. But if you have a high code coverage, you can't really say that, oh, your code works, all right? So going back to the example of the login form validation, and we have already seen this particular login view at the earlier parts of our application. I'm doing it over here, is form valid. And the first question people ask is that, well, how do I test it? How do I test it's form valid? How do I test my code works or not? Well, I would really just test it manually. All right, just using Xcode previews. There's another session by Apple. Actually, you can see the screenshot in my Swift data article. I don't really want to pull it up over here now. But actually, you know what? I will pull it up because somebody will bring it up and I will pull it up over here. So I considered, and I talked about it actually very earlier on, that I considered Xcode previews to be like test. All right. So if I scroll down in my article, I talked about it somewhere. You can see it's a long article. There we go. So in March 2023, I talked about that lately I've been thinking that how Xcode previews are like red, green, refactor, and TDD. Preview acts as your test data and previews shows visual indication, blah, blah, blah. All right. And after March, in June, Apple said pretty much the same exact thing with different wording, that previews are like test. And I agree with Apple. Previews are like test for your visual interface. Yes. All right. Now, just because you can test in previews does not mean that you would let go of your domain test. So for this kind of a thing, I will write manually tested in Xcode previews, and I'll be happy with it. I'll be confident that it will work. But then you'll be like, well, I really want to write a test. So what should I do? Okay, well, if you really want to write a test, you can extract that actual login form logic into a struct And now you have a username and password in a struct, and there's a property called isFormValid, and now you can write unit tests against it, kind of like this. All right. For me, it's a waste of time. For you, it will make you happy. That's fine. Good job. That's perfectly fine with me. Take a look at another example over here. Filtered products over here. We're filtering the products based on, I think, the min and the max values and kind of like a pricing. Will I test this out? I would probably just test it using Xcode previews. It is not that complicated. I will just use Xcode previews. It's more of a transformation logic, filtering logic right inside my view. But having said that, if you do want to test it out, you can again extract it out into a product filter form, just like a normal struct, and then write tests with it. So you can test it out. All right. You know, we all have a lot of work to do at our job. We have limited resources, and when you're writing these tests, you have to be very careful that you're using those resources in a much better way. So try to find out the places in your application that actually makes money. That's the hardest thing, the domain. And I haven't really even touched the domain yet, by the way, right? I mean, these are not domain stuff. This is just filtering logic, right? A domain would be kind of like, well, if I apply a coupon, and if I apply one coupon, I get 10% discount. If I apply 2 coupons, I should get 20% discount, and the limit will be 2 coupons. So that's a domain logic. I would not do that domain logic right inside my view. That's the actual heart of the application that makes you money, right? So all of those things should be in the actual model of your application, not inside the view. Now, here's another thing. Don't write unit tests for your view model to verify the user interface. And when people read this, they're always like, hey, you said don't write unit tests for view model. No, I didn't say that. I said don't write unit tests for view model to verify the user interface. You should read the whole sentence, what I'm saying, right? And people are like, okay. Well, let's go ahead and take a look at a very simple example. Once again, I'm not saying, and you have to read the whole sentence, I'm not saying that you should not write tests for your view model, because sometimes you have that presentation logic. Sometimes you have those logical presentation transformation parts in your view model that you want to test if you're using the view model approach. So let's take a very simple example. Here's a very, 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 very simple example. I mean, it's literally a counter. So if you're using view model approach, you have a counter view model, you have a count property, you have an increment function. You have a counter view, which simply uses the counter view model and increment the counter, and it gets displayed to the view. And you're like, okay, I will write a test for it. Okay, yes, you wrote a test for your counter view model. You can do that. And when you call the increment function, it increments the count variable, which is right here. But I guess the million-dollar question is that, does that test confirm that your view is working? Right? It doesn't confirm anything. I mean, it confirms that the counter gets updated and all the logic in the counter view model is working, yeah, but it doesn't confirm anything about the view itself. It doesn't confirm that the label got displayed. It doesn't confirm that the button was pressed, right? So taking a look at this example, now what I've done in this example is I've removed a button. And I'm simply displaying hello world, but the test will still pass. And you will say, well, Azam, it's like common sense. Why are you even wasting our time to show this stuff? And I'll tell you why. I mean, I was not even about to show you this stuff, but I was in many different groups, right? So and there were people talking about, yeah, we don't really write tests for our view. We just test a view model, so it should just work. And I'm like, no, that's not right. All right. Now, if you want to test your view, then write the test for the view, or test it manually, or just leave it alone and don't do it. All right. So if you do want to test this, out, you will actually have to write an actual UI test, which is also known as the end-to-end test. End-to-end tests are actually great because they are the best defense against regression bugs because they test end to end. All right. So this is a great case for an end to, well, I mean, obviously, this is such a simple example. I wouldn't even bother testing anything. I'll just use Xcode previews to test out the user interface if I want to test it. But for complicated tasks, you should definitely write end-to-end test also. So write 2 good end-to-end tests per story and maybe 1 edge cases. And your end-to-end test should have a long, happy path. As a user, I should be able to log in. And when I log in, I go to my home screen and add something to my account, something like that. So that is a good test to write. All right, because that's like completely connecting all the end-to-end things. Test the behavior, not the implementation details. Whenever you write a function, whenever you add a new class, that should not dictate that, oh, I should be writing a test. No, test the behavior of the application, of the story, of the action that you're trying to, of the task, not the implementation details. Here's a very good example over here. Over here, we are writing a test to find out if the fetch products was called. That's testing the implementation details. We are testing that the particular function was called. We should never do that because we should be testing what the fetch products returned you, right? I mean, if somebody changed fetch products to get products, the test will fail, but it's still returning you the products. I mean, isn't that what you wanted? So that is what you should be testing. All right. Don't use mocks for managed dependencies. I mean, people love to use mocks. I mean, and sometimes when you use mocks, it's very hard to see what you're doing because in the end, you end up testing the mocks. And you pass the mocks to the mocks to the mocks as a dependency. So only use mocks for unmanaged dependencies. Unmanaged dependencies simply means dependencies that you don't control. So let's say that if I am building an application that has to integrate with some sort of a payment gateway, well, that's an unmanaged dependency. I don't control the payment gateway. So every time I hit the payment gateway, it's going to charge me 25 cents. All right. There's a great talk by In Cooper, which says, TDD, where did it go? Where did it all go wrong? I highly recommend that you see this talk. And he basically talks a lot about that, testing the behavior and not the implementation details. So this is a very, very, one of the best talks I've ever seen. Another thing about test is, in iOS community or in any other community, is the reason for isolation. Oh, your test should be fast. Your test should not touch the database. Your test should not touch the file system. All of this is completely wrong. All right. Your test can definitely touch the database. Your test can write to the database. It can delete. It can update. It can go ahead and also write files. And remember, test is the isolation. It's not the thing on the test. The main reason that you should be careful in doing those things is not that it is not allowed or right or wrong. The main reason that you should be careful when you're adding something or putting something in the database in a test is that you should not leave anything behind the test so that your next test will fail or pass because of it. So if you want to access a database in your unit test, that is perfectly fine as long as you delete that thing from the database before the next test runs. So basically in the teardown. All right. So if you want to go ahead and access a file or create a file in your unit test, that's perfectly fine. If you want to go ahead and run a unit test that will add some data to the database, obviously a test database, don't run test against production, but your test, your local development, your development database, go ahead, it's fine. Just make sure you remove it after the test is done. All right. Ken Beck, who is the creator of TDD, wrote this quite some time back in 2008, that I get paid for code that work, not for tests. So my philosophy is to test as little as possible. Obviously, Ken Beck is not saying that don't test, but Ken Beck is simply saying that definitely you should write tests, but be very careful what you're testing. You should not waste your time in writing tests that doesn't make any sense. So find the parts of your application, of your project, your product that makes you the most money, which basically is mostly the domain part of it, and test it thoroughly. Let's talk about a little bit about SwiftUI rendering versus re-evaluation. Okay, we're running really out of time also, but rendering versus re-evaluation. When I was learning SwiftUI, I was always under the impression that when in a view, when the body gets executed, that means that the view gets re-rendered, meaning the whole view will be recreated. And I believe that for a very long time, that oh, the body is getting invoked, the body is getting rendered. This means a body is, getting evaluated or whatever. This means that the view is getting re-rendered. So if I go over here and run this application and press the count button, the button over here, right over, where am I? Yeah, this one, if I press the button, this is going to run this part. And print changes is simply a helper function from SwiftUI team that will show you that what actually has changed, all right? So it's not some function that I implemented. So every time you click a button, the body will run. And I was thinking that, oh, it's actually getting re-rendered. Like everything inside the body is getting re-rendered. It's going to completely disregard everything and create everything from scratch. And I was wrong. It doesn't do it this way. Because think about it. I mean, isn't it like a really wasteful thing to do? I mean, if you are incrementing the button, again, I'm lost. Here we go. If you are pressing the button is incrementing this count. The only person who is actually using the count is the text. I mean, nobody else is using the count. I mean, if you look at over here, that is, the list is not using the count. The button is not really using the count. The text is not really using the count. So the only thing that gets rendered will be the text for the button, all right? And that is actually what's going on. There is a difference between body is being re-evaluated versus body is being re-rendered. Re-evaluation simply means that SwiftUI is going to look at the body really quickly and find out if something has changed. But re-rendered means that SwiftUI has already found something that has changed and it's going to redraw it, all right? So just like I said, the text with the count property is the only one that's getting redrawn again, because that's the only one that actually changed. So behind the scene, what's going on is kind of like this, the structure, if you want to see. And when the text is changing, it destroys the view, and then it recreates only that view. All right. Yeah, we're actually at 11, and I have a lot of slides to go, but I'll post the slides somewhere. But I also do want you to ask questions. So, Navati, is it?
Yeah.
Yeah.
For sure. If you have some time.
But definitely. I mean, we have seen the main or the important part of the presentation. The other parts are, you can definitely when you look at the slides, and I'll post a link to the slides. You can look at it. But I'll just quickly go through the final slides. All of this stuff you can find it and you can understand it on your own. Let me go ahead. I have so much animations going on over here. I shouldn't. Oh, let me just jump over here, because I do want you to have questions also. All right, so we'll just start from here. So final thoughts is SwiftUI is the future of app development. Obviously, we know that. Don't fight the framework, because every time I have seen myself fighting SwiftUI, that, oh no, I want to use it this way, it just makes a mess. All right. Read Apple documentation and obviously watch the videos for WWDC. This is a slide that you probably should take a picture of. This is, and I'll share a link also. Let me see if I can. I don't think I can copy it from here. But yeah, but this is the picture that you can take. You can also get the slides over there. So the first link is for the references, the resources that were used in the in the presentation, and the second link is obviously for the slides.
Great.
Right. And this is my contact. I'm at azamsharp@gmail.com. I'm on Twitter at azamsharp. The question is, what is the best way to passing data from parent to child and vice versa? So in a SwiftUI application, from parent to child, if you want to pass, I mean, you simply parent to child, you just pass the data in a constructor or an initializer. If you want to pass from child to parent, then at binding is what you're looking for. At binding is one of the things that you can use. All right, and I will see if I can copy this. So these will be the slides. Okay, any other questions? And that will be the resources.
Perfect. Thank you.
There you go.
Yeah, we have a question. Two questions. Great. So one is when to use environment or presence keys by Santosh.
I have actually not used when to use environment. Environment, you mean like the environment? I don't have the code over here, but environment, you mean environment values, I guess. So I'm going to answer it like that, I guess. Environment values are basically, I think I have something over here. Environment values are basically used when you are passing, I guess they're used for like when you inject something in the parent or in the parent and it's available to the view, like this one. You can see that I am accessing from the environment HTTP client, although in this case, it's not really even needed. I can just create a HTTP client just by creating a variable of HTTP client. The most use cases for the environment values I have seen is that if you are distributing a framework which should have predefined keys in it. So think about SwiftUI that has environment keys for for manage object context, that has environment keys for dismiss. Remember dismiss. You can use environment keys for dark mode and all those things. So Apple is distributing this framework and it already has predefined keys. If you in a company are creating your own framework, you can define your own environment keys. So everyone will know that, oh, HTTP client, I can just access it like this. All right.
Great.
Yeah, using the VM approach, what I understand is that we are using the same model source to some extent across different portions of the app, which means we might end up bloating the model and adding new functionality to the big model could impact other parts of the app. Any thoughts how to better handle this? Using the view model approach, using the same model source. Yeah, so same model source you are providing. So this will be used, this part. So this is your same model. I call it aggregate model. Actually, a better example would be their own code, like this one, right? And so in a small or medium-sized app, you can get away with just creating a single model for your entire application. And if you look at the applications like Fruta, Food Truck, they are not really small. I mean, they are kind of like a medium-sized application and kind of like Apple gets away with just creating one single model. I think they call it Food Truck model, which is right here, right? So they do the same thing. I guess your question might be, which will it impact big apps? Well, if your app is big, then you should probably divide it like this. So if you're building an e-commerce application, it has a catalog, it has inventory, it has fulfillment, it has whatever an e-commerce application has, then you can create multiple models. Make sure that you understand these models don't really talk to each other like this. They don't. So if the catalog needs something from fulfillment, then it should ask the service and get it from the service. So these models don't talk to each other. None of these things should be talking to each other, because then you are using observable object inside observable object, and that's going to open up a different kind of worms that you don't want to deal with. All right. So if you want something, if an inventory is like, hey, I want something from catalog, okay, go get it yourself. Here's a service, make a request and get it yourself. All right. What's the difference between an aggregate model and a manager? Well, manager, I mean, they can have different meaning. I mean, aggregate model is a domain-driven term. An aggregate model is basically a model that contains or manages some other models. So if you're talking about the catalog, let's say catalog in a domain, a catalog can be managing a product. And I'm just making this up because I'm not familiar with this domain. A product, line item, I guess, right? So catalog will become kind of like your aggregate model, and that will be able to provide you a list of products, list of line items, and other things related to the catalog. I don't know what other things are related to catalog in e-commerce application, but whatever the other things are, then you can use that. A manager term it can have different meanings, but what I have done in the past is use different managers for database operations. Like a manager will use a data access layer to persist information. So we have a login manager, catalog manager, inventory manager. I guess they can have like a little bit of a same meaning as the aggregate model. Aggregate model is more of a domain-driven term, and manager is like, oh, it's going to perform some action on it, which I guess the aggregate model also does. So they can be used. So if you want to just create food truck manager that manages the entire state of the application, that is also fine. And some people also call it like service, right? Like catalog service, inventory service. Some people like to call it store, catalog store, inventory store. All right. So we should not inject core data save context using environment. We should not inject core data save context using environment. If I have to write a core data application, I would actually access the manage object context through the use of environment, and I would just call the save function on the manage object context inside my view. I don't know if that answers the question, but maybe the answer of the question will be somewhere in my other article over here. So this is for Swift data, and I don't know if I have. I guess we can see it over here. There we go. This might give you a little bit of idea. So this is Swift data, which is obviously different from a little bit different from core data. I create a recipe. This is inside a view, by the way. I do something with the ingredients, blah, 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 and then I call insert and I'm done. So inside the view, I have access to the manage object context or model context in Swift data, and I can just save it inside the view and done. All right. Now I can, and I did, you can move it all inside your recipe model. Like you can have a save function over here also. But when I did that, I had a little bit of an issue with using the previews, because now somehow the recipe will need to access the model context, and that was becoming messy. So I'm like, okay, and then the question is, but our app will be tightly coupled with core data. That's an excellent question, and that is the question that leads to another article that I wrote, which is the what if architecture, right? So your assumptions should not be based on something that may never happen. Your assumptions should be based on the business requirements. So what if your app is tightly coupled with core data? Let's say that you're using fetch requests, right, inside the view, and now you're like, oh, I want to use Firebase. Then you have to calculate what is there's no answer. That's $1 million question. That's why we get paid, right? But in those cases, the only answer is you should make sure that when you're creating your views, that your container view, which is kind of like a top level view, is the one who is performing all the action for fetching the information and then passing it down to the other child views. So the child views will always get an array of array of items, array of customer, array of recipes. So if something happens and you're like, well, now we're not really using core data, we're going to use Realm, then only those container views on the top, those are the ones that's going to get changed, because the child views, you just need to pass the array of items to it and they'll be done. But that is $1 million question with no answer. But one suggestion I can make is, how often does it happen? That is only you know. If you plan your application around that it will happen, how much time will it take you to write all the protocols, all the different things to make those layers? Is that time worth the investment? Is that time worth to maintain? Or if it changes, what will be the cost of change, cost of carry, cost of change? All of these things you have to calculate. And usually when we say that, oh, what if we are not using core data, we're using Firebase? Usually when we even layer our applications in a nice way, and that does happen, the reality is so different from our assumptions that it doesn't work most of the time. Like the requirements are so different and the architecture is so different. I mean, obviously Firebase is very different from core data, right? So it's so different that the assumptions that we made, the protocols that we made, and all of those things that we made, they don't work. But that's a question with no answer, basically. In other words, if it changed, yes, you will have to go to all of your container views and change it to Realm, right? But if it doesn't change, then all the code that you have been writing, well, that was a what if architecture, right? It never happened. Does it happen often in an industry? Not really. I mean, I would say maybe it happens 10% of the time. I mean, how many applications that we have worked on that 6 months into the project, they're like, we're just gonna use Firebase. I mean, it doesn't happen often, right? So we are trying to do something that may not yield the results. It can happen, but it may not. All right. But that's a good question, and unfortunately, that's a question with no answer. It's only your best judgment that you can make, right? So.
Yeah, great. This was a really insightful session. Thank you so much, Azam.
Yeah, thanks for having me.
Yeah, and yeah, folks, you can always continue the discussion even after this. And yeah, thank you so much for joining us. And thank you, Azam, again, and we'll see you soon again. Yeah.
Thank you so much. Yeah, thanks for having me.
Yeah, thank you, folks. Take care.
Thanks, everyone. I have to jump into a meeting, but I'll follow me online and I'll be able to answer you any questions. Thank you.
Thank you. Great.
Bye.
Have a good Friday. Bye.